Alright, so here we are with the very first unit for chemistry, and this unit is entitled Matter and Measurement, and you can see on your notes that there are 25 vocabulary terms, and you'll notice that some of them are in red. Um, I believe you might want to check number 7 because I'm not sure if it's in red on your version, but it should be. And the reason why some are red is because those are the real terms that you really need to know the definition for. The other terms, you're not going to really have to define them. They're more of a concept than a vocabulary term. But the ones that are in red, you should certainly be able to define. So let's go on. And you'll notice that every unit not only has a vocabulary, it also has unit objectives. And you can see what we mean by an objective. It's at the end of this unit, you should be able to do all of the following. That will give you a true sense of the material in a unit and hopefully will help you to do well on the exam. Alright, so first let's take a look at it. Chemistry is basically defined as the study of matter, and you can see the definition of matter is anything that has mass and takes up space, and taking up space means volume. That is one of your vocabulary terms. So pretty much everything that you can think of would be considered matter. A couple of things that would not would be heat or light, both of which are forms of energy. Neither one has mass or takes up space, so they would not be considered matter. But for the most part, most other things that you can think of are considered matter. And what we have here is what's called a graphic organizer, or in a way a flow chart. And what it does is it's telling you that matter, all matter, can be broken down into two subcategories. You'll see on this side that one of the categories that can be broken down into would be pure substances. And pure substances cannot be separated by physical means. And we'll explain to you what we mean by physical means in a second. The other subcategory of matter would be mixtures. And mixtures can be separated by physical means. Now, what do we mean by physical means? Well, physical means that there's no chemical reaction involved. So some of the examples of physical means of separating the components of a mixture would be filtration, evaporation, and we'll talk more about those later. So basically, matter is broken down into two subcategories: pure substances, which can't be separated by physical means, and mixtures, which can be separated by physical means. And then you're going to notice that each one of these is also broken down further. So let's take a look at pure substances and how they are broken down. Substances can be broken down even further into elements and compounds. Notice again, elements, which is the simplest form of matter, cannot be separated by chemical means. Meaning, if you have an element such as sodium, there's not really anything you can do to that atom of sodium to change it into anything chemically or physically for that matter. Compounds, on the other hand, because they are a chemical combination of two or more different elements, and those elements are simply bonded together, and you'll see what we mean by bonding later on, they can be separated by chemical means, and we're going to go through all of those different things. On the other side are mixtures. Mixtures can also be broken down further into homogeneous and heterogeneous mixtures. A homogeneous mixture means that the components are evenly distributed or has the uniform throughout. Alright, sorry about that. My fax machine was going off. So again, mixtures can be broken down into two subcategories also: homogeneous and heterogeneous mixtures. And the difference is, and we spend a lot of time on homogeneous mixtures, very little on heterogeneous. In fact, homogeneous mixtures, which are also known as, and that's what AKA is also known as, are called solutions. And we have a whole unit on that later on. So basically the difference is, in a homogeneous mixture, for the most part, you have something that dissolves in water. That makes a homogeneous mixture or a solution. For example, if you take a beaker of water and dissolve salt in it, that's now a homogeneous mixture or a solution. Iced tea is an example of a solution. Soda are examples of solutions. Heterogeneous mixtures are not uniform throughout, which means that the components are not evenly distributed. And I think probably the best example would be if I took a beaker of water, but instead of putting salt in it, which would dissolve, I'm going to put sand in it. Now we all know that sand doesn't dissolve in water. The sand will simply sit at the bottom. And that would make a heterogeneous mixture because the components, which are the sand and the water, are not evenly distributed. The sand is basically sitting at the bottom of the beaker. Particle diagrams are also extremely important, not just for this, but when we look at the phases of matter: solids, liquids, and gases. So if you look at this, this represents an element. In this particular case, it is a diatomic element. So this could be an example of Cl2. Notice how, even though you might think it's a compound because there are two atoms, they're both the same atom. You notice how both circles are open? That represents two of the same atoms bonded together. So this is not a compound, this is actually a diatomic element. A monatomic element would be, for example, one open circle by itself. What makes this an element, not a compound, is because they have the same atom bonded twice. If you look over here for compounds, you notice a compound has to consist of two or more different elements. So if you look at this one, you notice that this is an example of, let's say, for example, this could be water. The red one could represent oxygen, and the two open circles could represent hydrogens. Now, what makes this a compound is because you notice how these are touching each other, which means they're bonded, just like these two are. But the difference is that these are two different atoms bonded together. That makes this a compound. In this case, this would be a homogeneous mixture. You have two different components. They have the open circles and the closed circles, and they're for the most part evenly distributed. This would be an example of a heterogeneous mixture, where you have, let's see, 1, 2, 3, 4 different components, and notice that they're not really evenly distributed. That would be an example of a particle diagram for a heterogeneous mixture. Let's look at a couple of examples of practice problems. It says which particle diagram or diagrams represent a mixture. Well, this is just one compound. It's three particles of that same compound, so it's not a mixture. This is a monatomic element, not a mixture. This is our mixture right here. You have a mixture of two different elements, the element with the closed circle and the element with an open circle. So this is our mixture. Remember, mixtures can be two or more elements, two or more compounds, or it can be a combination of elements and compounds. And this, number 4, is similar to number 3. It's an element. It's just a diatomic element, so it is not a mixture. So only number 2 is a mixture in this particular case. Which particle diagram or diagrams represent a pure substance? Well, remember, a pure substance can be two things. It can be an element or a compound. Well, if you look at number 1, that's a compound, so that's a pure substance. Number 3 is an element, so far numbers 1 and 3 are possibilities. This is the same as this one here. We said that this is a mixture, so 2 is out. And this is also an element. So it looks like here, it's 1, 3, and 4 are examples of pure substances. Now, obviously on the Regents exam, if it's a multiple choice question, you would only have one correct answer. All right, number 3, which of the following particle diagrams represents a mixture of one compound and one element? Well, if you look at number 1, that's a compound, but so is this. So that's a mixture of two compounds, so that's not it. Let's see what we got here. Well, the dark circles, the black circles, are elements, and these are compounds. That's a mixture of one compound and one element, so number 2 is the answer. If you look at number 3, it's a mixture of two elements. They're both diatomic elements, but they're two elements. And number 4 should be fairly simple. A diatomic element would be number 2. This is two diatomic elements, and this is a compound. Okay, so that is the end of this lesson.